So you should always try to break up your task into smaller chunks, not just look at the whole picture. It's good to have the big picture in mind, but it's good to break your task into small chunks. Also, do not be scared to use Google, like I said before. Google is your PE, not just your best friend. So whatever you ask Google, will give to you. So don't be scared to ask Google. And then YouTube. YouTube is when I need to learn something, it's like my go-to place, right? Because I learn faster from watching videos than reading. I don't like to read like that per se. I read, but not that much. Aside Google and YouTube, I'm sure when you use Google, Google will lead you to there's Stack Overflow, there's Stack Exchange, there's W3 Schools. There are lots of places, a lot of resources that you can use. You can Google them up, and you will see them there. Together with the instruction for the task I was sent to you is a link that leads to understanding descriptive statistics, right? So I'll for the course of this call, I'll go through my Jupyter notebook, right? To give us understanding of what descriptive statistics looks like in Python, the Jupyter notebook. So, right, I'm sure you must have explored the tutorial videos for Python and R that were sent to you earlier. And then there are YouTube channels and data science blogs to help you with the depth of your understanding. Now, let me share a tip with you. During my time at Tutor, like I told you earlier, I had some form of programming experience before coming to Tutor, and I could already do data analysis to an extent, right? But when I needed to learn data science, I had a screen. You know, you can divide your phone's home page into different screens, right? So I had like 2 screens, all having shortcuts to tons of data science blogs. Now, I was working at that time, but I made sure to scan through each blog every day on a daily basis, right? So it helped me learn, like every day I was learning new stuff. Every day I was seeing new stuff. Every day I was seeing the capabilities that you can accomplish with data science. It helped build my curiosity. It helped build my hunger to want to learn more. So that's what I did then. So there are tons of data science blogs, KD Nuggets, there's even Kadu has a blog, there's 365 Data Science, there's Data Talks Club, there are tons of them that can help you with the depth of your understanding and depth of your knowledge in data science. So from here, I think I should go to my okay. From here, let's see. Hold on a minute. Okay. I need to move this stuff away from here. Okay. So let's see what the task looks like, right? Let's see what the task looks like before I head over to my Jupyter notebook. So okay. Like I said, the goal of this assessment is to test whether you have adequate working knowledge of Python, math, and probability to get started on this journey. And there's a tutorial that was shared with you on Python, and then where you can learn Python and some bit of extra reading. So there's also a bit of algebra, vectors and matrices. We'll see a little bit of those here. And then statistics, probability. I'm sure many of us must have heard of probability. And probability is actually one of the easiest parts of statistics. This aspect of probability that we'll be dealing with, I saw in the question, they are not in depth, they are very easy to understand. And also, there's math and machine learning. There's a book, please remind me, there's a book I would like to recommend to you guys. It is making a big wave in the data science world lately. With machine learning, it's mathematics for this machine learning. That's the name actually. I will share it with us later. I think I opened it somewhere on my browser. And then I'll check and I'll share it with us later. So like I mentioned, the tools that we'll need to be able to accomplish this task. You need a computer, internet, a web browser, Chrome, preferably, and then Python installed on your system, and then you need Microsoft Word, PowerPoint, or Google Slides, as the case may be. All right. So for the purpose of this task, we'll be using Python. So we can check out other alternatives later. Okay. So this of Python. So write it down. The first question is to write a program to find three numbers from an array, such as the sum of those three numbers will be equal to 0. I think at this time I will head over here. Okay, I said I'll give us a brief of what the descriptive statistics look like. I'll quickly run us through this notebook. Just so you know, this was my own submission when I wrote my for my application to student. I have not edited the descriptive statistics aspect of this. This is my own submission, so I'll basically just walk us through it as quickly as possible. Then we move on. So this is what Jupyter Notebook in Visual Studio Code looks like. This is the logo for Visual Studio Code. It's my preferred ID at the moment. Okay, so for this particular task, these are the libraries that I'm going to need, right? I'm sure we know how to install Python already on our system. Do we, or should I show us? Please, I'll need your response to it. Do we have problems with installing Python on our systems? Do we all have Pythons on our systems? Can you guys hear me?
You guys can unmute to respond to Ken or type.
We can hear you. We can hear you. I can hear you.
Okay. Do you have Python on your system, or do I go ahead to show you how to install Python?
No, I don't. I don't actually have a laptop. I'm using a friend's own, but he has on his system.
Okay, you guys can unmute and speak. That was one person that just spoke for herself. Hello, guys. You can unmute and speak.
Yes, I have Python installed in my system.
Okay, for the sake of time, maybe I should just go ahead and then assume that we already have Python in our systems, and then we just move. So already on my system, I have Python. I have all of these libraries installed. This is Pandas, the library that enables us work with data frame. Enables us work with data frame, and then in some cases make plots. Yes, that's what Pandas does, data frames. And then NumPy enables us to make calculations with Python. All of our plus, minus, divide, times, square root, and math functions, they are mostly inside the NumPy. Matplotlib is for data visualization. So what it does is that it enables us to plot graphs. Seaborn also is another visualization tool. It enables us to plot graphs also. Seaborn graphs are actually finer than what Matplotlib would look like. So most of us prefer to use Seaborn for plotting graphs, right? And then here is me importing my data set into Python. So to do this, I simply initialize my data as data. I can use any name. I can use df. I can use student performance. I can call my data set anything I want, but I'm choosing to call it data for the sake of this, right? And then this is me using PD. PD, remember here, I installed Pandas and I installed it as PD here. I installed Pandas as PD. So me calling PD here is me calling Pandas to help me load my data frame into Python. Remember, like I told us that Pandas helps us to work with our data frames. So me calling PD here is calling Pandas to help me load my data frame into Python and call it data, right? So I already have this data set in a CSV file somewhere on my system, my laptop, and I'm loading it in Python and calling it data, right? So now here, data.head, it's me trying to take a look at what the data looks like. I can see the different columns and I can see the first 5 rows of the data. I can decide to say, okay, I want to see the first 10 rows of my data. Okay, let me start clear out this. And then I run this formula again. Okay, so I'm running everything again so that we can be able to play with it a little while we move. So I can decide to call in the first 10 rows of my data using data.head and put 10 in brackets. So it's going to load the first 10 rows of my data for me. And if we can count, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of any data set in Python, is always, you don't want to see just 2 rows. All right, so I only want to see 2 rows, and it's going to load the first 2 rows for me, depending on what I want to see. So now I want to see the shape of the data. By the shape of the data, it's going to tell me the number of rows and the number of columns that we have on the data. So once I click this to run now, it's telling me that it is the rows that usually come first. So this here signifies the rows that we have on the data, and this signifies the columns. So this is telling me that we have 1,000 rows on our data set, and we have 8 columns. So if we count the number of columns that we have, there's 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 columns on our data. So quickly we'll head to the part of the descriptive statistics. Now, for us to have an understanding of what descriptive statistics means, let me quickly take us to Google. All right, so I'm going to go to Google. I'm going to search for descriptive statistics. Meaning of descriptive statistics. So Wikipedia, say a descriptive statistic is a summary statistics. Okay, it's a summary statistic that quantitatively describes or summarizes features from a collection of information, right? While descriptive statistics is the process of using and analyzing those statistics, right? So it means that descriptive statistics is going to give us, in terms of the quantity, certain features of the data. So it's actually going to be giving us numbers of different features of the data that we'd like to see. So the first thing that we want to do here is for this to describe the data for us. Now, what is going to happen here is that it's going to give us what we call a summary statistics of the data. And the fact that it's going to give us count. By the count here now, it's telling us the number of rows that we have. We already established earlier here that we have 1,000 rows. So this count is telling us the number of rows that we have. That we have 1,000 rows on this data. Now, it's also now if you take a look at the data again, you see that a part of the data are in text format, and these other parts are in numerical format, right? So these parts are called text variables, and these are numerical variables. Now we cannot perform summary statistics for text variables. We can only perform descriptive this function that we want numerical computation here. And we can perform for this numerical columns. That's why when we did this here, we are only seeing 3 columns: math score, reading score, and writing score, because we cannot compute the mean, median, or anything for this first 5 columns. They are text columns. So for these 3 columns that are numerical variables, we have 1,000 rows, Now, the mean of the math score is 66.009 approximately. The mean for the reading score is 69.17 approximately, while the mean for the writing score is 68.05 approximately. Now, we know the mean, right? But what does it mean? What does it mean tell us? The mean is trying to show us where the median score, where most of the scores is concentrated in this data. It's trying to show us the center of the scores. So it means that out of every score, the median score, this mean here is like a measure of central tendency. It's telling us the middle of the data distribution, right? We know what mean means. So it's telling us the middle of, so let's say, for example, the lowest score is, let's say 30, and then the highest score is somewhere around 90, right? So by the time we look for the mean, it's going to be somewhere around 90 plus 30 divided by 2, right? So that's going to give us something around, the median, and then it's going to give us 90 plus 30 divided by 2. It's going to be somewhere around 60. That will give us the median. So the mean in this case is telling us the center point of the data distribution between 30 and 90, right? The center position of the distribution of the reading score is 69.17, while the central position of the writing score is 68.05. Now, the standard deviation is trying to tell us how spread, like the spread of the data, how apart are they from each other, right? So what this is telling us that is that between different points in the distribution of the scores, how are they spread apart? So 15 is a relatively high standard deviation. So that tells us that there's a great deal of space between the score distribution. Between the highest and the lowest score, there's a white space in between. All right, that's what the standard deviation is telling us. So we see that the standard deviation is highest for the writing score, right? So it means the writing in the scores for the writing test, the difference between the highest and the lowest score is higher than it is for all the other scores. Now, the minimum score is 0 for math score. The minimum score is 0 for math score. The minimum score is 17 for reading score. The minimum score is 10 for the writing score. Now, the 25%, 50%, and 75% are what we call the quantile. So 25% is the first quartile, right? It tells us about the first 25% of the data. So if you're having 1,000 rows, the first 25% is 250 rows, right? So the first 250 rows is giving us the first quartile of the data. So the first 250 people, usually the first 250 scores lies around 57 for the math score. It's around 59 for the reading score. It's around 57.75 for the writing score. So the 50% is like the median score. Now, if you check the median score now, which is the 50, that's the second quartile, which is 50%. You see that it is similar to the mean. It's not so far apart from the mean. So the mean and the median in this case are quite similar. The difference between them is not that much, right? While the mean for the math score is 66.09 approximately, the median is actually 66. So there's a difference of 0.09, right? Now, while the mean score for the reading is 69.16, the median is actually 70. So this is a little bit high. Still less than 1. It's around 0.9 something or so, right? 0.8 something. Now, while the mean score for the writing score is 68.05, the median is 69. So we see that the values are quite similar to each other. They are not exactly the same thing, but they are quite close. Now, the 75% is called the third quartile. So it's showing us what the highest points of the data will look like, right? So this is trying to tell us that somewhere in the data, right? The highest score distribution is somewhere around 77. For the reading score, it's somewhere around 79. And for the writing score, it's somewhere around 79, right? Now, the maximum score is 100, right, across all the different scores, but they have different minimum scores. Now, to univariate analysis. Now, from the word univariate analysis, uni means one. Variate is another way of saying variable. So univariate analysis simply telling us that it's the analysis of one variable. So when you are doing univariate analysis, you are just looking at, you are taking one variable at a time. You are not comparing any two variables at the same time. So there are two ways we can do this, right? We can decide to just do value counts. Say, for example, for this first one here, we are looking at univariate analysis of both gender types, right? There are two gender types in this data. If we check from here, okay, there are two gender types, male and female, right? So we can see we want to know between the male and female which have a higher population, right? So we can select the column. Now the column is called gender, and it is on the data set that we need as data. So this is how we call the column from the data. We use data and we do this, and we put gender in a square bracket and in quotes. One other way we can do this is simply we can also do data. We can also write it as data dot gender, right? Then we'll do dot values dot value counts. It's going to give us the same answer, but I'm not going to advocate for this because it can lead to a lot of error, right? If you're not careful, I'll always advise you to go with this, right? It's going to help you avoid errors, right? So if we run this now, it's telling us that we have 518 females and we have 482 males. Now, this is one way of doing this. Some people are not so good with data, some just want to see visualization. So we can also do this with a count plot, a plot in Seaborn. Remember, I called Seaborn in here as SNS. So I put Seaborn as SNS. So this is me here calling Seaborn as SNS to do a count plot for me. And the gender I'm interested in, the column I'm interested in, which is my X, is the gender column, and it is in my data, right? The data that I see that data set that I see that data here, right? So I'm calling gender, the column gender from data to do a count plot for me using Seaborn. Now, when I do this, it's going to plot it. It's going to plot this for me, right? So if we check, we see that the bar for females is actually higher than the bar for males. So that means we have more females than males, just like it showed here that we have 518 females and 418 males, right? So we can go ahead and look at other columns. Here, I look at groups, ethnicity, right? So I'm interested to see which ethnicity has the highest population. So when I click this, the same way I called in my gender column here, right? To do this count, count for me, the same way I am calling the ethnicity here in terms of the group. So now I'm calling this group to do for my data set to do a values of count for me. So it's telling me that group C has the highest population, 319, the ethnicity that has this group, right? And then group D is 262, group B is 190, and then group E is 140. We can also go ahead and do a bar plot and see SNS.count plot, SNS.count plots, right? We're interested in our column called data and call them group. In our column called group, right? And we save it in our data set that we label as data, right? Just like we did in the other side. And then when we do this, it's going to plot it for us. So we see that group C actually has the highest, just like it's stated here. Group C has the highest, 319. Group C has the highest bar, followed by group G, right? Then followed followed by group B, then group E, and group A has the smallest population, just like stated here, right? So we can go ahead and do for other columns. For the sake of time, I won't be plotting all of this, but we have seen how to plot those already here. All right, so I did the same thing for the parents' education. It showed that of the students, 226 parents actually have some college degree, 222 have associate degree, 196 went to high school, or 179 went to some high school, but not very specific. 118 has bachelor's degree of the parents, and then 59 of the parents actually has master's degree, right? So we can do the same thing for the lunch variable, and then we see that 664 had standard lunch, while 355 had probably had maybe free or cheap lunch, right? So we can do the same thing to see those that are prepared for this test, and then you see that 642 actually did not complete the test, while 350 completed the test, right? So that's it about univariate analysis. You see that we're only looking at one variable per time. Now, for multivariate analysis, this is a little bit complex, and the best way to usually do multivariate analysis is using visualizations, not just counts, not just counting values. Say, for example, now with this here, we're trying to. Okay, before we do this, let's see what multivariate means. I'm not sure. I don't think we should go to Google. Judging by the fact of what univariate analysis means, we'll simply know that multivariate analysis is trying to compare more than one variable. Sometimes it can be two, sometimes it can be three, right? Depending on what the analysis is trying to look at. So for this now, this is trying to compare the different test scores between math, reading, and writing of both gender. So we are looking at the test scores based on gender for this particular cell. Once I run this now, it's going to bring a chart, right? For math score, it's showing me that more males actually had high scores in math than females. And then more females had high scores in reading than males, right? And then there were more females who had good scores as compared to the males in writing. All right, so this is me now trying to compare gender and then test scores for different type of tests, math tests, reading tests, and then writing tests. Also, I can decide to say, okay, the difference of the different ethnicities, I want to compare their performance in the test. Let's see which ethnicity did well, which ethnicity that time very high scores in the test. So to do this now, that's what this cell is trying to do for me now. It's going to bring another chart for me, right? Another bar chart, right? Comparing the different ethnicities with test scores also. So we see that group E actually had better scores for the reading. Group E also had the best scores for writing. Group E also had the best scores for math. So we see that group E were all round, they were the best, followed by group D too. You see that group D had the second highest bar here, and here too, right? Then there's group C, right? So in order of ranking, the top three groups are group E, group D, and group C in terms of performance in the test. So I can also do this for, this is comparing the lunch type and the test scores to see how lunch type of lunch that they had during lectures and classes affected their performance in the test. So if we run this now, right? So we're going to see that those who had standard lunch performed better in the reading test than those who had free lunch. Those who had standard lunch performed better in the writing test than those who had free lunch. Those who had standard lunch performed better in math than those who had free lunch. So we see that the lunch types actually, the type of lunch that they had during classes has a way of affecting their performances also. Right, so we can go on and can explore and look at the different variables. I'll quickly move ahead from this so that I'll get to other parts of this test. Okay, this is me doing the same thing for test preparation, parents' level of education, and all the others. This is me completing pass or fail. So I'll skip all of this and then we'll head to test proper, right? Let me skip all of this. So to the task at hand, the task that you were given, what I was talking about was descriptive statistics and motivate and univariate analysis and how to go about them using Python, right? So you basically make use of charts to do motivate analysis. So one of the things that you need to learn very well in data science is how to make charts, beautiful charts. There are different packages to do that. There's Matplotlib, there's Seaborn, there's also Plotly. Plotly make interactive charts. I don't have any Plotly charts here that I've shared with you. Maybe on my repository somewhere. Right. So we'll head on to the task today, right? On the basics of Python that you were given. So we are going to see. So the first question we asked was to write a Python program to find 3 numbers from an array such that the sum of those 3 numbers will be equal to 0. So this means that you'll be given any random collection of numbers in an array, maybe a set or something. You have random numbers, and then you have to write a program which will automatically select 3 of them, such that those 3 that it selects, when you add them up together, they will amount to 0. I don't know, Shay, am I allowed to share code? Shay?
Hey, Ken. Yes, I can hear you.
Am I allowed to show codes?
Yes,
yes.
Yes.
Okay.
Thank you. We want to help them as much as possible.
All right. Okay, so for that first task, right, this is how I went about it. Now I'm going to I'll break down this code for you line by line, try to explain to you what every line does. Now, this first line I'm importing a library called itertools. Itertools is what we use for iteration. Use them to iterate or loop over a given array or series. Now, what I did is this. Now, this here, right? So this is me declaring what we call a function in Python, right? So I declared a function and I call the function sum to 0, right? And the input of that function is going to be an array, which I called ARR, right? A short form of writing array. I can go ahead and spell full array, but I prefer to just leave it this way for time's sake, for speed. Okay, so I declared that function, and I said I want the input of that function to be an array, and the name of that array is ARR. So I can do 2 things here, right? Now, when the array comes in, I can decide to sort the array. This is me sorting the array now using the sort function. So I can decide to sort the array and then write them in a function in a way that takes the highest number first or the lowest number first. Right? In this case now, saying reverse is true, so it's going to take the highest number first, right? And it's going to take from the highest number, it's going to compare from the top down and pick 4 numbers, right? So if okay, I'll come back to this. So it's just basically it's going to sort the array for me, right? And now for this is me telling Python that for every 3 numbers that you pick in that array, I want you to iterate them, right? For every 3 numbers, if I'm using itertools, for every 3 numbers, that's why I call them triplets. For every 3 numbers in my array, using this itertools.combination that I imported from here. Now, I want you to check the sum. I told Python that I want you to check the sum of the triplets for me, right? If they are equal to 0. If by the time Python does the sum and it equals to 0, it's going to return those three numbers for me, right? Otherwise, it should just give me an error. It will give me an error message if that's not true, right? And this is me saying return to close my function, right? To print out a list for me, right? Or an array, depends. Now, this is me declaring the first set of array, right? I pick four random. I can pick any four random numbers. This is the first one, and this is me declaring my second array, right? So now this is going to print for the first array, which I named nums1. Now it's going to print this sum to 0 function for me. Now remember that I said that this sum to 0 function is going to take an array of any amount of numbers, right? It's going to sort it for me. It's going to iterate over it, and then it's going to sum it to see if it is equal to 0. And then if it is equal to 0, it's going to print out the numbers for me. That's what this function does, right? So this me to 0 here, which is actually the name of this my function here, right? It's asking Python to perform this function that I've written here on this set of array here. Similarly, me calling sum to 0 here is me asking Python to perform this function on this second set of array here. So if we run this now, you see now that it started from the highest number, started from 4, started from 2, right? 2 is the highest number here. It started from 2, it picked 2, and then it saw -1 and saw another -1, and then picked them together. If you add 2 minus 1 minus 1, it's going to amount to 0, right? Similarly, it started from the highest number here, right? The highest number being 10, right? So it picked 10. After picking 10, it saw -7 and it saw -3, right? And it picked them together because 10 minus 3 minus 7 is going to sum up to 0, right? Now, I can also decide that, okay, I don't want Python to sort this array for me. I just want the array to come in raw format, the way I put it in, to just pick any number that it will amount, that will sum up to 0, right? So now me putting an hashtag over here means I'm commenting out this row, this code that I've written here. It's not going to run because I made it a comment now. It's no longer a code. It's just me blabbing inside Python, right? So if I run this, we see that the answer will change somehow, right? So now it's not starting from the highest number again. It's starting from the first number in the array that came out. So we see that -1 is the first number that came, 0 is the second number that came, 1 is the third number that came. And it did this too and found out that actually -1 plus 0 plus 1 is going to amount to 0. So it picked it for me because that's what I have asked it to do. Similarly, on this my second set of arrays, -25 is the first number. I can't pick -25 and did -10 and did -7. Python saw that no, these ones are way too big, right? So it didn't pick it because if you check in actual fact, I don't think there's anything here that you can do -25 with to actually get 0. So it came down to 10, which is the next number. So after picking 10, Python saw 8 and it saw 2, right? So -10 plus 2 plus 8 is actually going to amount to 10 too, right? So that's how I went about this. There are other ways anybody could have done this. There are other ways anybody could have done this. Some solutions are longer because the conditions were explicitly listed. Now, if you check for the sake of performance, right, it took me just 0.3 seconds to run this code. If you see here, this is counting the time for me. It took me just 0.3 seconds. There are some other solutions that can take up to 10 seconds, 15 seconds. They are not optimized. So this is I think this is the most optimized way of doing this, except maybe of course there are others available in other places, right? Now, so that's the solution for this last one here, right? Where you ask to write a Python program to find the 3 numbers from an array such that the sum of the 3 numbers will be equal to 0. right? So that's the solution right there. Now, for the second, for number 2 of the basics of Python task, you have to write a Python program to add 2 binary numbers, right? Now, we know binary numbers, they are not the usual numbers in base 10 that we know. The highest number in any binary number is 1. There is no 2. Because once it's 2, this is no longer in base 2. It is now above base 2. Right? So once you write a function that will pick a number in binary format and then do the sum and then output the answer also in binary format, right? So this is the solution for that. This is quite lengthy because there are a lot of things to consider. So now, again, I started my solution with a function like I did. Anywhere you see def, anything in Python, this is me defining a function, right? So I defined a function to collect 2 binary numbers, x and y, right? Now, of that x and y, I want to know what the maximum length is, right? That is the number, the amount of the numbers that are need. If there are 4 numbers for that binary number, if there are 3 numbers, if there are 2 numbers, if there's just 1 number, I want to know. And I want to know the highest number. So what this is going to do for me is, for my x, it's going to pick the highest. That's please, and I have to mute somebody. Please check your speakers if you are not muted. Quite distracting. Mute yourself, please. Okay, so for these my functions, right? I'm picking the maximum length. So if there are 4 numbers in that binary number, it's going to pick 4. If there are 3 numbers, it's going to pick 3, right? And I'm going to save them here in a container called max length, right? So here, this is me trying to normalize it with the zfill function. Now I'm going to do 2 things. Now, if I don't know if we still remember how to solve binary numbers. We know that when solving binary numbers, right? Something is common. Let me just do this. So when solving binary numbers, we know that when we add 1 plus 1 in binary, it's supposed to equal to 10. Do we know that? So 1 plus 1 in binary is 10, while 1 plus 0 is 1, right? So now we need to find a way to do something. What if in binary we have 11 plus 1, right? This will no longer equal to 10. The way we are going to do this by this calculation is this. Now, 1 plus 1 normally is 10, right? So we are going to write down 0, and we are going to carry 1. That 1 plus 1 will make 10, plus another 1 will now make 11. So this will be our answer, right? So we need to define a way where we'll be able to when we perform an addition, we need to find a way to be able to carry over the 1 when we need to carry and print the result when we need to print, right? So that's why we are declaring a result and a carry, right? Now, for this next chunk of code here, right? This is me. This is trying to explain when to carry and when to print the result, right? Now, so I'm giving condition here that for any particular number or any particular member in the range of max length minus 1. Remember that we've already defined max length as the maximum length, right? So when we are performing calculations, and we need to carry over, we need to carry over backwards. That's why there's max length minus 1, right? We need to carry over backwards. Right? That's why there's minus 1 here, right? So now, here's me trying to tell Python now that for any particular number in the range of max length, from max length to -1 at -1 steps, right? So I'm starting from max length and I'm stopping at -1 and I'm going at -1 step. So I'm going back, I'm counting back, right? Now, when I'm performing calculations and then I get to a point when 1 + 1 is 10 and I need to write down 0 and carry 1, I'm asking Python to carry for me here, right? To carry. Now, when I carry and I perform a summation, now when I carry, whenever I carry is going to be saved as arrow. Now, when I carry, right, arrow changes value to 1. So when I perform 1 + 1 will be equal to something. If it is 1, it's going to print 1. Otherwise, it will do 0 and carry again. So it will keep carrying and carrying and carrying until it no longer carries and gets me, and we get to the last element of max length, and then to print the final answer, right? So that's what this statement here does for me, right? Okay, so this is not useful. I'll take it away. All right, so now, when after I have carried the result, now I'm going to print the result. I'll print 1 if the number that I'm carrying divided by 2 is equal to 1. Example, I do 1 + 1. 1 + 1 is 2, right? When I divide by 2 and there's no remainder, how do I put this for you guys so you understand? Okay, when I do this and there's no remainder and I add to max results, right, it's going to print the result for me. Otherwise, it's going to carry over and then print. If it is less than 2, it will just, if I carry over and it is less than 2, then it's going to print 1. Otherwise, if it is 0, it's going to print 0. That is what this statement here does, right? So if carry is not 0, print 1 plus results plus whatever it's saved as results here. So when we run this, right, it's going to return the result for us, and it's going to normalize it the way we've normalized it here before. And so when we run this now, +111, we want to add 110 plus 111, and then we add 1111 plus 1000. So when we do this now, it's going to print all 3 results for us. Now, if we do this addition manually now let's try. We're starting from the last 2 numbers. We are going to start with this 1 plus this 1. So basically, this is what we are doing. The first step we'll do is we'll do 1 + 1. 1 + 1, right? This in binary is supposed to give us 10. So we are going to write down 0 and carry 1. The 1 that we are going to carry, we are going to add it to this 0 here, this 0 in the middle, yeah, right? So it's going to become 1 plus 0, right? Remember, we've carried 0. We carry 0 here. So that we write 0 and carry 1 here, right? So now that one that we carry plus 0 in the middle here plus 1 in the middle here, 1 in the middle of here, right? So that will give us another +1, right? So this will give us another 10. This will give us another 10, which we are going to write down 0 and carry another 1, right? Then we'll bring that one that we'll carry here and we'll do 1 + 1, 1 + 1, right? Plus this 1. We've added the 1 that we carried to this 1. We are going to add it to this 1 again, +1, right? So it's going to give us 10 + 1, which is 11. So in other words, our final answer is going to be 1 1 0 0. Starting from here, starting from the back, we're going to have 1 1, then we are going to add 0, and then we are going to add 0. That will be what our answer is, which is what we have here. If we do the same calculation using binary, we'll get this same answer and this same answer for this other 2, right? So this is the solution. They are like like in other, I said before, there are different ways of solving any problems using Python. You can do it your own way. You can use any other format. You get the same answer, right? But it's just a matter of optimized code. For example, my code just took 0.2 seconds to run. You could do yours and it take 15 seconds, 20 seconds, depends. Right? So code optimization is a very important factor. Right? So that's the solution for the second question, which is when they ask us to write a Python program to add two binary numbers. Right? So now the third question is this. Say she used an online Python compiler. What is the output of the following? Now, this here now, without using the idea, I'm going to try to break this down for us. What is happening here? So the first thing is that we have declared a dummy variable. Okay, don't let me call it the dummy. We've declared a variable, right? On the first line. Let me come to my ID. I think I wrote it here. Okay, so we've declared a variable as 1 on this first line, right? We call it I. Now, we want to find out on the condition that I is true. On the condition that I is true, if it performs I divided by 7 and there's no remainder, this here is called the modulo, right? What it does is it prints the remainder of a division. So if I do 2 modulo 2, it's going to give me 0. Do you know why? Because when I divide 2 with 2, the answer is 1, right? But there's no remainder. Normally 2 divided by 2, this is divide. 2 divided by 2 is going to give me 1. But the modulo doesn't work this way. The modulo only prints the remainder, right? So 2 divided by 2 is going to be 1, remainder 0, right? So now, while I is true, right? Why? As long as I is true, as long as I remains within this condition that when you divide I by 7, the remainder is going to be 0. As long as that condition is not satisfied, I want you to loop over this entire loop here and keep increasing I by 1. That's what I'm telling this program to do for me. As long as I divided by 7, right, is 0. As long as this condition remains, it is not satisfied, go over this loop. But as long immediately this condition is satisfied, you break the loop and end there. That is what is happening here. So if I run this now, it's going to run this code for me. It's going to do I equal to 1. It will perform 1 divided by 7. Of course, there will be remainder because 1 divided by 7 is not a whole number, right? So once it does that, it's going to print 1 for me, but this condition is not met. So it's going to increase I by 1. So it will do I here is already 1. I here is already 1. When it performs this and this condition is not met, right, it will print I and then it will increase I by 1. So I will become 2 and perform the same loop again. Now do 2 divided by 7. As long as it is not 0, right, it will go on again, print 2, and then do the loop again until it gets to a point where I divided by 7 will have no remainder. And at that point, I will have to be equal to 7. So that 7 divided by 7 will be 1, remainder 0. Immediately that condition is satisfied, then the loop is going to break and it's not going to continue. So the output for this is going to look like this, right? So it's going to print 1, 2, 3, 4, 5, 6, because for all of this condition is not satisfied. Up until 6. When you do 6 over 7, 6 divided by 7, it's going to give you a fraction because there will be remainder. But as soon as it performs 7 divided by 7 and finds out that 7 divided by 7 is actually 1, remember 0, it's going to stop the loop there. It's not going to print 7 again. So that's what this code would do. That's what the output looks like, right? So that's it for this question. Let's see. Okay, I think I didn't. The next question, which is question 4, is asking us that in Python, suppose a list is given as this. What is list this, right? So what this will do is this. Now, suppose you are given this list here as is written here, right? You are given this list here. I called it num list, right? And this is the list. Now, what this will do for me is that I'm asking Python to print all the numbers, all the elements, all the content on this list and leave the last one. In Python, when you talk of -1, you are going to the end of an array or end of a list or end of a set, depending on whatever it is that you are -1, right? So I'm asking it to print everything before the last one. So as soon as it gets to the last one, it's not going to print it for me. It will print all the others except the last one. So when I run this now, we see that it printed 2, which is the first one. It printed 33, which is the second one. Printed 222, which is the third one. Printed 14, which is the fourth one, but it didn't print 25 because I asked it to leave the last one out, right? So this is what the output will look like. So what that code is telling, what this code is asking Python to do, right, is to print all the elements in that list and leave out the last one. All right. So I'll go to the next one. I'm trying to move as fast as possible so I can finish on time. Then the last one says, what is the output of the code below? What is the output of the code below? Right. So this is a function, like I told you before, that whenever you see def in Python, it means it's a function. So here I'm defining a function, right? Another function, I'm asking it to return. Now, Boolean, I hope you know what Boolean means. Boolean is it's either true or false. When you ask it to print a Boolean function, you're asking it to print true or false, right? So now, I've declared a function. What this code does is it declares a function and asks you to print true or false for where x divided by 2 will not have a remainder, right? That's what this code is asking you to do. So when you divide x by 2, any number that is given, right? When you divide it by 2 and there's a remainder, it will print true that there's a remainder, right? But where there is no remainder, it will print false. Where there is a remainder, it will print true. But where there is no remainder, it's going to print false because we've asked it to print a Boolean, right? So now we're selecting 20 and 21, right? Now let's run this. We see that for 20, when you divide 2 by 20, there is no remainder, so it's printing false. But when you divide 2 by 21, there is a remainder, it's printing true. If I decide to say, okay, I don't want you to divide by 2, I want you to divide by 3, right? Now, if we look at it, if we divide 20 by 3, there will not be a remainder, so it should print true here. If we divide 21 by 3, there should not be a remainder, so it should print false here. So this condition here is supposed to reverse. Now let's take a look. Now we see that it has reversed because when you actually divide 21 by 3, there's no remainder, so it's going to print false. When you divide 20 by 3, there's a remainder, so it's going to print true. So this function prints whether true or false. Prints true when a number supplied to it does not have has a remainder, and prints false when there is no remainder, right? That's what this function does. Okay, I think that's the last question for the basics of Python. Do we have questions before I move on to the basic of math? I can take one or two questions to make sure we are clear before I move on. If you have questions, you can ask quickly, then we move on. You can unmute your mic and speak if you have questions. Are we even here at all? Or let me talking to myself.
Hi,
Hello, guys.
Joy, Idris. You can unmute
Okay, Joy.
to respond to Ken's question. Hello.
Are we here?
Okay, let's see. Hi, Idris. Hi, Joy. I'm actually asking you both to unmute your mic. Okay. Are you guys still with Ken?
Yes.
Amazing, amazing.
Is it boring? Or are you guys already getting scared?
I'm really trying to. It's not boring, but I'm just trying to cope.
Okay, because is it the code?
Yeah.
Okay. Now there's one thing I want you to do. I don't want you to be scared, or I don't want you to start developing code feet, right? Remember what I said from the beginning of everything, that Google is your friend, right? Rome was not built in a day. I didn't start to write. I didn't just wake up one morning and start to. It took a while. It took a lot of Googling and a lot of YouTube, right? And then I'll see what people have done, take it, and then try to modify it, see what the result is like, try to delete something, add another thing, see what is going to happen. So with that, I started to master one or two things. I started to understand some of other things also. So I encourage you to do the same. Don't just look this and start becoming scared. There is Google that you can use. There is YouTube. Don't be scared to ask those two questions. They will help you actually. All right. Don't be scared. Ask
Yes,
questions.
thank
Ask
you.
questions. I'll give you an answer. Okay. For the basics of math part, this is a lot easier, right? So I'm not even going to be spending too much time on this. You have to give brief definitions of all of these. The truth is that if you don't know them, if you Google them, you get tons and tons and tons of answers. Tons and tons. There are plenty. So I did not even bother to give definitions to this because they are everywhere all over the internet. You will find them. The rank of a matrix, the trace of a matrix, eigenvalue, the inverse of a matrix, they are all there, right? You can find them. But I can help with these other ones, and I'll explain them. Hopefully, these ones are less technical, so you are going to be able to understand these ones quickly. No, so now for the parts of the components and magnitude of a vector V with initial points A, this, and B, this, right? I didn't use exactly the same values as you were giving, but I used my own values, but it is the same thing. Now, the solution should look like this now. The vector is a straight line in a Cartesian plane. A Cartesian plane simply means remember how you used to plot graph, and then you draw your x-axis and your y-axis, right? And then you label x and y. That's a Cartesian plane. Now, a vector are points, 2 points, right? A straight line vector is a straight line on any 2 points, right? So it's a straight line on any 2 points on that Cartesian plane, right? So with that, when you have that idea that it is that, then it's easy for you to be able to do computation. on it. So the axis of that vector is going to be this A and this B, right? This is the starting point, the initial point, and this is the end point, just like you have the beginning of a line and the end of a line, and they both have coordinates on the Cartesian plane. I wish I still had that tab open. I would have showed you something. Let me Google Cartesian plane for you to see what it looks like. Cartesian plane. Right, so see what a Cartesian plane looks like, right? Yeah, these are different examples of Cartesian planes, right? So a good example of what vectors look like. This is a good example of what a vector looks like. A starting point and an end point. So this is usually a straight line, right? But simply, okay, to make this easy, let me just do this. You see what you see that I'm using Google now to find a good example for you now. This is an example of a vector in a Cartesian plane. Right? This is another example of two vectors in a Cartesian plane. This is an example of three vectors in a Cartesian plane. This is 1, this is 2, and this is 3.
Can you still hear me?
Yes, clearly.
Can you hear me?
Yes.
Yes, I can hear you.
Hello, guys.
Is that Joy Joseph?
Yes,
Hello?
Joy.
Yes,
But
Joy
your voice
Joseph,
is
we can hear you.
echoing. I can hear you. Voice echoing also.
Hello?
I can hear you. I can hear you.
Can you guys hear me?
Hello, I can hear you.
Hello, Shelly.
Yes. Can everyone hear me?
Can't hear you guys anymore.
Hi, Ken. Can it?
So maybe I should leave and then join again because I can't hear you guys. I can't hear you, Shelly. I
Idris.
can see your mic is moving, but I'm not hearing you at all. So I'm going to leave and then join again.
Okay. Hi, Joy and Idris. Can you guys still hear me?
Yes, I can hear you
Okay.
clearly.
Okay, let's wait for Ken to rejoin.
Okay.
Apologies.
Hello, can you hear me now?
Yes, I can hear you.
Yes. Welcome back, Ken.
Thank you. I think I hear you now. Okay, so this is where I was. Right, so I was trying to show you what a vector look like. Now, to get the component of the vector, right? Say for example, let me choose this image now. This would be a perfect way to. Sorry, I've not shared my screen. Let me share my screen again. Okay, Shay, you have to make me the host so I can share my screen again.
Okay, on it. Okay, please try now. You should be able to share your screen now.
Yes. Coming up. All right. So I was trying to show us this image earlier. So this image here is a perfect example of what we can work with, right? So this is so this here is our point A, and this here is our point B, right? So our point A has coordinates 0, 0. So this first 0 is our X coordinates. This second 0 is our Y coordinates, right? And this is for our point A. Now for point B, this is our X coordinates, and this is our Y coordinates, right? Now to get the components of this vector, we simply do this X minus this X, this Y minus this Y, right? That's how we get the components. So now coming here, oh, I don't know why this. All right. So coming here, to get the component of the vector, we simply take the X components of the, X component of the B point, so the X components of the A point from it. Then we take the Y component of point B and subtract the Y component of point A. So with this now, it's going to be 7 minus 2 and 10 minus 5, right? So 7 minus 2 is going to give us 5. 10 minus 5 is going to give us 5. So this is the component, right? It is simply X of point B minus X of point A, then comma Y of point B minus Y of point A. That's the component of the vector. Now to get the magnitude, it's simply finding the it's simply squaring up these components, right? So it's simply doing, for this X, you do X squared, and then you add it to Y squared. And it's represented by the vector annotation with in between two pipes, right? In between double pipes. So now this is the representation. And then we take X squared and then add it to Y squared. So doing that, we'll have 5 squared plus 5 squared, which is 5 times 5 plus 5 times 5. That's 25 plus 25, which is 50, right? For this, my example here. So that's how I got the components and the magnitude. Now, the magnitude is a single figure, while the component will still be in X and Y format, like any of the points, right? Only we will have subtracted point A from point B, or subtracted point 1 from point 2. That's the difference. So when looking for the component, you subtract the first point from the second point. And then to find the magnitude, you square both components. You square the X component and square the Y component, right? That's the solution to this. Now, for the question 3, it's a simple algebra where simplify the expressions. They're just simply asking you to write this in a way that we'll not have A twice, we'll only have A once, we'll only have B once, then plus any number that follows, right? In a very simple format. But I didn't solve this because I believe that it is something we should be able to. So maybe let me see if I can do that here, right? So now this is what it is. So for me to do this, I'll follow BODMAS, right? Remember I added BODMAS here. So if I follow BODMAS, B in BODMAS is for brackets, so I have to take away all the brackets. If I do that, I'll have 2 times A, which is 2A, and I have 2 times minus 3. That'll be minus 6, right? I'll just take out the brackets. Once I take out the brackets, it will be easier for me to collect like terms and then sum everything up. That's just the solution for this. Open the brackets up, collect like terms, and sum them up. And then you have your final answer, right? So don't let me go further with that. Now, on the basics of probability, Now, there are general principles or rules of thumb when dealing with probability. Now, the first thing you always want to do is to find out the total possible outcomes, right? Say, for example, if you roll a die, there are 6 possible outcomes because a die has numbers from 1 to 6. There are 6 faces on the die, so there are 6 possible outcomes. So when you roll a die, there are 6 possible outcomes. Now, count the number of possible outcomes. Like I said, in a die, it's 6. In a coin, it is 2 because you have just head and tail. Now, you find the distribution of the outcomes in cases where, for example, like the second test I was giving, the second question I was giving to us under the probability, where probably in a class, you have 5 Igbo boys, 2 Yoruba boys, 3 Hausa boys. You have to know this distribution, right? So if, say you have 5 Igbo boys, 3 Yoruba boys, 2 Hausa boys, that is 10 already, right? So you know that there are 10 possible outcomes to pick from, right? So if you want to find the probability of picking an Igbo boy, since you have 3 Igbo boys in that class, the probability of picking an Igbo boy will be those 3 Igbo boys divided by the total possible outcomes, which is 10. That will be 3 over 10. That's the probability of picking an Igbo boy. So, for example, when a coin is where a coin is tossed, now there are 2 possible outcomes, right? So the possibility of getting a head is just 1 out of 2 possible outcomes because the head can only happen once when you toss a coin once, right? In rolling a die, the probability of getting a 3, right, is just 1 over 6 because a 3 has the possibility of happening just once out of 6 possible outcomes. But in terms of even numbers, if you want to get the the probability of getting an even number, then you have to count the amount of even numbers that you have on that die and divide it by the total possible outcome. That's going to give you your answer, right? Now, for the other case where you have to group them, like I mentioned in the classroom of 5 Igbo boys, 3 Yoruba boys, 2 Hausa boys, right? Total possible outcome is 10. So possibility of picking an Hausa boy when you want to pick at random will be the 2 Hausa boys that is possible that is in the class divided by the total number of people in the class. So that will be 2 out of 6 and 2 out of 10, sorry. So that's how to go about the probability. I wish I had more time to do more examples, but I'll just have to leave it at this for the sake of time. I can take questions now if you have questions. If there's something you need me to still clarify on the probability and on the math, you can signify quickly so we can take that. And you guys have
very much, Ken. Yeah, so Idris and Joy, do you guys have any questions?
From my end, no.
Okay, amazing. How about Idris?
Yeah, it's fine. We can proceed.
Amazing.
Okay.
Okay.
All right. And please do not forget, like I've always said from the beginning, Google is your PA. Whatever it is you need to do, and like I remember someone told me when I started programming generally, that there is nothing you want to do under the sun that is entirely new from beginning to end. At least a process of it, some part of it must have been done somewhere before, if only you know how to look for it, right? So don't be scared for looking out for pieces of solutions to this problem and then fitting them together. It's part of problem solving skill. And in case you don't know, Googling is a skill now. People add it to their CVs. Don't be scared of using it. It will help you a lot.